got another harder titration calculation for you to try, so here it is. If you want to pause the video and then just play on for the answers. Okay, so as always I've got my little diagram to help explain what's going on. So we've got this many grams of A, it's been dissolved in a 250 cm3 volumetric flask. That's gone into the burette and it's titrated against samples, 25 cm3 samples of 0.112 mole per decimeter cube sodium hydroxide, and the mean titer of A was found to be 27.30 cm cubed. We are also told that the mole ratio is 1 mole of A reacts with 2 moles of sodium hydroxide, and we've got to give our final answer to the nearest whole number. Okay, so the first thing I'm going to do is work out how many moles of sodium hydroxide was used in the titration. So that's concentration times volume, but we have to put the volume in decimeters cubed. So that's coming out at 2.8 times 10 to the minus 3 moles of sodium hydroxide. Next thing we can do is use that mole ratio they gave us to work out the moles of A that must have been present in that mean titer. So that's going to be half of 2.8 times 10 to the minus 3. So now we know how many moles of A were in the mean titer. We need to work out how many moles of A were actually in the original solution, which is also going to be equal to the moles of A in the 1.513 grams. So we need to scale up. So we're going to divide 1.4 times 10 to the minus 3 by the mean titer. That's going to give us how many moles of A is in 1 cubic centimetre, and then multiply up to 250. That's coming out at 0.0128 dot dot dot. So I've got the full number in the calculator, but I'll just report it to those 3 significant figures there. So the next thing we need to do is work out the MR of A. So we know the mass, we know how many moles was present, so MR is mass over moles. So that's coming out at 118.014, so to the nearest whole number it's 118.